Hello, welcome to Physics Lesson 3, Momentum and Impasse. If you remember in Lesson 2, I promised you that I would start from this question here where we have two trolleys A and B which collide head-on. Trolley A of mass 4 kgs moving east initially, that's before collision, at 10 meters per second, and trolley B moving west at 8 meters per second before collision. And after collision, trolley A moves west at 14 meters per second, while trolley B has a velocity of v. We do not know whether it's moving west or east. The mass of trolley B is not given, and the final velocity of trolley B is also not given. But if you remember in that example, we had a mass here of 8 kgs, and the final velocity of trolley B was actually 4 meters per second east. And I promised you that would work start from the fact that this collision is elastic and move backwards and determine the value of m, which is mass of trolley B, and also value of v, which is the velocity of trolley B just after collision. Now the compass is given obviously, so we have east, west. Normally we say right or left, but in this case we have east or west. Now question A says determine m, the mass of trolley B, and then we also have B here. Determine v, the velocity of trolley B just after collision. So how do we handle this question? Well, we operate from two principles. Like I said in the previous lesson, questions of this nature where you are told the collision is elastic, you operate from two principles. One, we assume the system is isolated, and therefore the law of conservation of linear momentum applies, and that's where we start from. So answer says total linear momentum final is equal to total linear momentum initial. Let's choose the right as positive. So two principles. First principle is conservation of linear momentum. The second principle is the fact that the collision is elastic, and therefore total initial kinetic energy equals total final kinetic energy. So let's start from this one then. So what it means here is mass of trolley A times V final of trolley A plus mass of trolley B times V final of trolley B. That is total final momentum. That should be equal to mass of trolley A times V initial of trolley A plus mass of trolley B times V initial of trolley B. That's total initial momentum. Now we know the mass of trolley A is 4. Mass of trolley B is not given. Mass of trolley A is 4. Mass of trolley B is not given. Let's put in velocities. Do we know the final velocity of trolley A? Yes. It's 14 meters per second west. Therefore, it must carry a minus sign, because if east is positive, west must be negative. So we have minus 14 here. Do we know the final velocity of trolley B? Final velocity of trolley B is not given, so we just leave it as V. Do we know initial velocity of trolley A? Yes, it's given here as 10 meters per second east, and we took east as positive, therefore the 10 must carry a plus sign. Do we know initial velocity of trolley B? Yes, it's 8 meters per second west, and if east is positive, west must be negative, so this must be minus 8. Let's simplify this. This is minus 56 plus mv is equal to 40 minus 8m. Adding 56 on both sides, or transposing minus 56, we're going to get mv is equal to 40 plus 56 minus 8m. And 40 plus 56 is 96 minus 8m is equal to mv. I see m here and I see m here, so therefore it is easier to make v subject of formula. I'm going to use term-wise division, divide by m here, divide by m there, and divide by m there. And so what I have is v is equal to 96 over m minus 8. This is equation 1. Let's call it equation 1. We have been able to obtain this equation from the principle or the law of conservation of linear momentum. But we're told the collision is elastic. And therefore, let's move to page 2, where we're going to use the second principle. And the second principle says that total kinetic energy, total initial kinetic energy must be equal to total final kinetic energy because the collision is elastic. So we're now going to say total initial kinetic energy must be equal to total final kinetic energy, EK final. Why? The collision is elastic. That's the reason. And so what does this mean? This means half of mass of total A times V initial of total A squared plus half mass of total B times V initial of total B squared. This must be equal to half mass of total A times V final of total A squared plus half mass of total B times V final of total B squared. Let us substitute what we know. This is half mass of total A is 4 kgs. Initial velocity of total A, if you remember, is positive 10, and we have to square this, plus half mass of total B is not given. V initial of total B is minus 8. We have to square that. Notice here, initial of B is minus 8. Initial of A is positive 10. Final of A is minus 14. Final of B is just V because we don't know what that is. All right, so let's move on then. So this is equal to half mass of total A is 4. Do we know final velocity of total A? Yes, minus 14. We're squaring this plus half. Do we know mass of total B? No. Do we know final velocity of total B? No. They've just given it as B. Next, this is 100 times 2. Half of 4 is 2 times 100 is 200 plus minus 8 squared in brackets like so. It is 64. Divided by 2 or multiply by half is 32. And we have M there. This is equal to, that's minus 14. We square that is 196 times 2 is 392. I think 392. 0.5 times 4 times 14, let's say minus 14 squared, 392. So this is 392 plus, on the end there we just have half m v squared. Now let us add or subtract 200 from both sides, or add minus 200 from on both sides. So transpose the 200. In other words, 32m equals 392 minus 200 plus half m v squared. This is 32m equals 192 plus half m v squared. Getting rid of this half here, how do we do that? Multiply throughout by 2. So 2 times this number here is going to be 64m equals 2 times this number here. 2 times 2 is 4 times 19 is 38. So this is 384 plus half of m v squared times 2, and these 2's cancel. So we have 64 m equals 384 plus m v squared. Let us call this equation number 2. Now, solving of simultaneous equations is extremely critical in physics, chemistry, statistics, whatever science discipline you're pursuing. Remember, you need to develop techniques, or you need to revise methods of solving simultaneous equations from the lower grades, lower grades. If you're in grade 12 watching this video from South Africa, you need to go back to grade 10 work and just do a quick revision of solving of simultaneous equations there. Right. Next, to solve these two equations simultaneously, we have to substitute this equation into equation number 2, because I see v here and I see v squared here. So sub equation 1 into equation 2 to get 64m is equal to 384 plus m, open brackets, and we have 96 over m minus 8, and the whole thing has to be squared. Remember, v is 96 over m minus 8, and it has to be squared there. At this stage, I want to remind you, remember the video I posted on algebra, one of the videos I posted there, I talked about this famous expression, a minus b squared, or a plus b squared, whatever the sign you have in the center there, or in between a and b. I told you that this, how to expand it, you take a, multiply by itself, a squared. You take a and b, multiply them, ab, then double that. The sign here is minus, respect it. If I had a plus sign, it would be plus here. B times itself, you get b squared. Now applying this principle there, what you get is the following: 64m from there, remember, is equal to 384. Keep your m outside, and then you have 96 squared all over m squared minus this times that times 2, so 2 times 96 over m times 8, and then we have to say plus 8 times itself is 64. Right, now let's do the simple expansion now, removing these square brackets here. So 64 m is equal to 384 plus m times 96 squared over m squared. M cancels one m and you're left with m down there. So this is 96 squared over m. And then m times this one here, the m's cancel. And when you multiply these out, you are supposed to get 1536. And then you have m times 64 is supposed to be positive 64m, obviously. And if you notice this and that, if you transpose this to the other side, you're going to get 64m minus 64m is equal to these two up here. You're going to have 96 squared over m, and then 384 minus that, it will give you minus 1152. Let's check. 384 minus 1536. Yes, 1152. This one here is 0 is equal to 96 squared over m minus 1152. Add 1152 on both sides. 0 plus 1152, you have 1152 is equal to 96 squared over m. Add 1152, the 1152's cancel, or just take this one to the other side, you get this. Next, we move on to page 3. Continuing solving this equation here takes us to page 3. We are now saying multiply both sides by m. So what do you have? What you have now is, remember, I said we multiply both sides by m. So you get 1152 m is equal to 96 squared over m times m. The m's cancel here, and you have 1152 m equals 96 squared. And to solve for m, we have to divide by 1152 on both sides. 1152. These cancel, and so your m, if you do the cancellation there, it must give you 8. Mass is measured in kilograms, so it's 8 kgs. But let's just confirm this. 96 squared divided by 1152. Yes, our answer is 8. So that is part A. Part A, determine mass. So we're finding our answer, mass of trolley B. So we got that. But B requires us to find V, which is velocity of trolley B just after collision. Now, in order to determine that, we're going to use this equation over here. This equation over here. V equals 96 over m minus 8. Because we now know what the value of m is, we can simply say part B says V equals 96 over m minus 8, and we know what our m is, 96 over 8 minus 8, and we know 96 over 8 is 12, minus 8, and we know 12 minus 8 is 4. But this 4 has to be positive because it is positive from here, but we have to emphasize that there's a plus sign here, and meters per second in which direction? East. And we're not changing it because our answer turns out to be positive, and we chose the east as positive. So this is how you go about this. You classify this as maybe the most difficult, arguably the most difficult question on the law of conservation of linear momentum. And so the takeaway here is to understand that we're using two principles: the principle of conservation of linear momentum, and we're also using the principle of conservation of kinetic energy. Total kinetic energy initial equals total kinetic energy final. Why? Because the collision is elastic. Form two equations. The first one we had is this one here, equation 1 over here, and then we had to form equation number 2, and we had to solve the two equations simultaneously, and we were able to obtain our value of mass as 8 kgs and final velocity of trolley B as 4 meters per second east. If you go back to lesson 2, you'll see that this was an example that I had given the velocity and the mass, and we needed to calculate velocity of this one trolley B just after collision, which we of course worked out as 4 meters per second east. But I promised you that I was going to hide M and V and then work from backwards forward, work from the fact that the collision is elastic and move backwards, and determine the value of M and the velocity of trolley B just after collision. So this is where I'm going to stop in this video. My next video is going to be dealing with the graphs, the graph of momentum versus time, and we would want to look at how do we use the law of conservation of linear momentum if you're given a graph of momentum versus time before the collision, during the collision, and after the collision. And also, how would you determine how would you determine impasse if you're given the graph of net force versus time? So this is where I'm going to stop, and our next video will cover that and perhaps finish this topic, and then we'll move on to other topics. See you next video.